Hey guys, hello everyone. Welcome to Rasayan Academy once again, all of you. So I just hope that you have already visited the CSIR UGCNet website, the NTA website, and you have already seen this notification. If you have not, I'm informing you all. So this has come out yesterday, 4th of September, and the final schedule for your CSIR NET GRS and LS examination for assistant professor is already out. The exam is going to be in CBT mode. You already know that. What are the dates? Let's quickly see. So starting from 16th is the date for Earth, Atmospheric Sciences, Ocean and Planetary Sciences examination. For 16th, in the second shift, you are having physical sciences exam. Okay, in the same shift, you are having physical science. Then in the second shift, you are going to have mathematical sciences. Now for 17th, you have two examinations in the morning and in the evening shift. Once again, both life sciences and chemical sciences, only one. That is 18th of September. In the morning shift, you are going to have chemical sciences. I think you will be happy that in the morning shift, you are having the examination so that when you are fresh and you are able to apply your knowledge in the morning shift. So this is going to be really good for all the chemical science students that we are not put into the second shift, okay, where we are already a little bit lousy. Okay, so yes, it's really good. And since the yes, it's really good that you are getting on 18th of September. The date is out finally. So when are you going to be able to download the admit cards and the city intimation slip on by 10th September and 13th September respectively. Okay, so admit card will be released by 13th September. Okay. So yes, you are going to be able to check all of these information on the CSIR NTA website. Okay, so now guys, there is something really important that we want to discuss. Now today I am going to discuss another short topic with all of you: protection and deprotection. Is it a whole chapter? Is it enough for the syllabus for your CSIR NET examination? Absolutely not. Okay, and specifically guys, I am making these last minute practice videos for all of you, not considering that you will be able to understand everything if you are a starter. But for now, for this point of time, for those students who really need some push to, add their marks to get from 60 to 90. Okay, so these videos are for those students who already have their basics cleared and they just want a little bit of push. Okay, so what about those who want to, let's say, just start their preparation? So guys, I have planned something, but after this examination only, I will be able to start from the very basic. Okay, right now is not the time to do all the topics from the very basic. That is why I am just trying to help all of those students who are interested in organic, or let's say as a whole in gaining marks from doing little topics at this point of time. Okay, so at this point, protection and deprotection is just one little topic of the whole organic reagents chapter. But yes, all the organic reagents, doing them right now, learning from them is not possible, so I'm just helping you a little bit to fetch marks. Okay, so I just hope that if you are interested, you can watch this video whole, or if you are not interested, then you can, if you're just starting your preparation, then you can just try to study organic reagent from the very basic thoroughly. Okay. So yes, now at this point of time, I'll make you, study few important protection, deprotection reactions, because they have been asked in your CSI NET and GATE examination, and I have also shown you some GATE and CSI NET questions in the end of this video to solve them and try to do these questions by yourself, so that simultaneously practice is also done. Okay. So first thing guys, what are the important protecting and deprotecting protecting groups basically? Yes. First of all, the protection of the nitrogen group, protection of the oxygen group, these are the most frequently asked ones. Okay, and there are plenty of protection and deprotection agents. So we just want to study the most basic ones first of all. Okay. Yes. So first thing guys, see, look at this: N-benzyl amines. What are benzyl amines? That is when I am saying that NCH2PH, that is benzyl amine. Okay, so whenever there is this group, directly when pH is connected, we don't say it is benzyl, we say it is phenyl. Okay, yes, it is phenyl, and CH2PH is benzyl. This is benzyl, okay, and we are also going to do IUPAC nomenclature, aromaticity, everything, but from the very basic after the examination, okay? Yes. Now, what do we see, guys? N-benzyl amine over here. All right. How do we form the N-benzyl amine? Protection is very easy. You are just going to take BNBr or some other good leaving group, PH, CH2Br. This is exactly benzyl bromide. Benzyl bromide. This is exactly what is written over here, BNBr. Okay, benzyl bromide. So the nitrogen is a good nucleophile. It is going to attack on this carbon, and the bromine leaves SN2 attack simple. And when there are two protons to be lost, you can have two substitutions like this. When there is one proton to be lost, that in a secondary amine, then you're only going to have one nitrogen and benzyl bond. Okay, so the protection is easy, and the deprotection is also very easy. Whenever you are getting anything, any heteroatom, that could be X, that could be Cl, oxygen, nitrogen, any heteroatom on the benzylic position, then by catalytic hydrogenation you can simply remove it. Okay, catalytic hydrogenation is going to help you remove this heteroatom and give you toluene, and whatever is the heteroatom, it gives you that product also. So here it is the amine, so you get the primary amine and secondary amine back as it is, and what happens to the benzyl group? That becomes toluene. That becomes toluene. Okay, so this is very simple, guys. And there is one more selectivity thing that we have to take care of when we are studying the N-benzylamine. That is, if you have benzyl ether and N-benzylamine. So this is a benzyl amine, okay, and this is a benzyl ether. Definitely we can make a benzyl ether also when we are protecting the alcohol, right? So let's say both of these are protected. Now, if I want to do the deprotection, which of them is going to be deprotected first? By the catalytic hydrogenation. So first, always the amine is going to be deprotected, 90% amine. And if the conditions are really drastic, then only the benzyl ether is going to break the bonds. Ethers are more stable than amines. Okay, you must remember this. That is why the amine is going to break down easily. So first protecting agent we have learned is the amine protection by the benzyl bromide. Protection is very simple, taking a benzyl bromide, and the deprotection is very simple, catalytic hydrogenation to do the heteroatom cleavage on the benzylic position. Okay. Next, we move onwards. The same protection of the amines. We have amines, we could have primary or secondary amine. Okay. How are they going to be protected, guys? By formation of carbamates. What are carbamates? See, this is a simple carboxylic acid. This is a simple carboxylic acid, but if we are putting a nitrogen over here, that is the carbonyl is forming amide kind of linkage too. That is going to be your carbamate in this way. Carbamates are extremely unstable, so they are going to break down in the presence of, let's say, strong acid also. So let's see over here, you have 1 degree amine. 1 degree amine, when you are having, you can take this kind of a dialkyl carbonate molecule, or you can also take the chlorocarbonate like this. Look at this chloro molecule. So what happens is the nitrogen is going to attack over this carbonyl, bond opens up, falls back, and the Cl minus is going to leave, because Cl minus is a better leaving group as compared to this OR. Okay. So that happens. You have got the carbamate, very good. What was required? Only a base. Okay, basic condition was required when your carbamates are formed. Okay, not a problem. Acha, one thing also I forgot to tell you about this N-benzylamine. Guys, whenever we want to protect a molecule, we consider that which condition is it stable to. It is stable to both acids and bases, right? Because when you are saying that there is deprotection taking place in the presence of catalytic hydrogenation, which means that the nitrogen carbon bond is a very strong one. Okay, and it is a very less polar bond also. So this bond is going to be strong, not broken in the presence of acid and bases, specifically bases. Okay, so we also have to see what is it stable to. Okay, we move onwards, we see carbamates. So carbamates are supposed to be stable to bases. Okay, they are going to be stable to bases because they are formed in the presence of a base, right? So it is going to be stable to a base only. All right. Now you have formed the carbamate, guys. Okay. Now how are you going to do the deprotection of carbamate? That is also very, very important to consider. Yes. One thing important is how are you going to do the deprotection? So you want to break this bond, and that is why you require some nucleophile. Some nucleophile which may attack this carbonyl, and the bond might open up from this side. Okay. If that happens, see, if that happens, you're going to end up with N minus and COOR and the nucleophile like this. Okay. So how is it going to be, guys? It could happen in the presence of, look at this, trimethyl silyl iodide. Why? Because oxygen has a huge affinity for silicon, and that is going to make this carbon more and more electrophilic for the iodide attack. Okay. So it could be deprotected in the presence of a silyl halide that gives you your amine once again, or let's say specifically if we have some particular carbamate. There are two important carbamates that we are going to look at. First one is CBZ. CBZ protecting group, that is your carboxybenzyl. Carboxybenzyl. See, there is benzyl once again, and whenever there is benzyl, that is CH2PH, we can use the catalytic hydrogenation as the deprotecting agent. Let's see. So let's say this is your amino acid molecule. Okay, so this is an amino acid, guys, and you have a secondary amine over here. Now, once again, I am taking this molecule where I have a benzyl oxy group, carbonyl and benzyl oxy group. So the Cl minus is going to be removed very, very simply. See, you just look at one carbonyl. You are going to do some attack on the carbonyl. Which is a better leaving group? Only you have to consider that. Which is a better leaving group? Absolutely, Cl minus is a better leaving group than the oxygen. It is always the case. Okay. So oxygen is going to stay, and that is why the molecule, the nitrogen which is present, it is going to be protected like this. COOOBN like this. Okay. It is protected. The acid is as it is. Acid का protection नहीं हो रहा है. The nitrogen is protected. Carboxybenzyl group like this. Okay. Now what is next? Next is once again you have phenyl CH2O double bond O. This has been a question in your CSIR net examination कि अगर मैं carboxy benzyl group को, if this group I am doing the catalytic hydrogenation, what will be the product? The products will be carbon dioxide emission. Look at this. Carbon dioxide will be emitted. Toluene will be emitted. Toluene is going to be one of the products, and secondary amine to hai hi, definitely there is going to be secondary amine, but along with that you will have carbon dioxide and PHCH3 toluene. So this CBZ specifically has this benzyl oxy group, and that is why for deprotection you can use the same thing that we have used in the benzylamines, catalytic hydrogenation. Okay. Also, we have one more very, very important group, that is the Boc protecting group. Benzyloxycarbonyl. Benzyloxycarbonyl. So, what is so important about it? Let's see. So, for the protection, you're going to use the Boc anhydride. Acha, Boc anhydride, what is that, guys? What is Boc anhydride? It is very, very simple. Anhydrides are always like this. This is always the structure of the anhydride, isn't it? Yes. What else do you have? You have oxygen and tertiary butyl group, nothing else. This is Boc. Basically the butyl oxy. Not Boc, but butyl oxy. So this is also butyl and oxy. Butyl oxy. So Boc anhydride means butyl oxycarbonyl anhydride. So this is butyl oxy, this is carbonyl carbonyl, and this is anhydride, butyl oxycarbonyl anhydride. Okay. Absolutely. So let's say you are having once again this alpha amino acid, phenylalanine you are having, for example. So in the presence of an amine, extra proton is removed. Yes, and you are providing benzyl oxycarbonyl anhydride. So it is protected like this. The carboxyl group. Okay, so the amine is going to attack over here, let's say, and the whole group eliminates. तो सिर्फ इतना portion रहेगा. What is this portion? It is butyl oxycarbonyl, Boc. Okay, so yeah, sorry guys, not benzyl, it is butyl oxycarbonyl. Tertiary butyl oxycarbonyl, ठीक है? Yes. So tertiary butyl oxy and carbonyl. This is your Boc protecting group. Okay, so I just hope that this made sense to all of you who are watching this video. Boc protecting group is very simple, and it is very specific that you take trifluoroacetic acid. Okay, so whenever you are given match the following or any other type of question where you have trifluoroacetic acid, you are going to list it down for Boc protecting group only. Okay, it is a strong acid. Anything special about the fluoride? No, it is just a strong acid. Or you can also take dilute HCl, which is also a strong acid. Okay, it will be deprotected. So this part is the deprotection, giving you the amino acid once again. And what else is eliminated, guys? So look at this amine. Look at this amine, guys. Once it has formed this carbamate, butyl oxycarbamate, what happens is the bond is going to fall up. How does the bond fall up, guys? Yes, in the presence of an acid, in the presence of an acid, this is how it's going to break apart. So this is only a rough mechanism. First of all, definitely the nitrogen is protonated and then the whole reaction is going to move onwards. But I'm just showing you a rough mechanism that this is how it happens. Elimination of CO2, isobutylene you are going to have, and this is your amine once again. Okay, Boc protection and deprotection. So once again, what is Boc going to be stable to? Boc is going to be stable to the bases once again, stable towards bases and catalytic hydrogenation also. It is going to be stable because tertiary butyl group is a bulky group, so it is not going to favor that catalytic hydrogenation. Benzylic ethers. So we have just seen that how benzyl amines were formed and how it was more reactive in the presence of benzyl ether, which means that benzyl ethers must be really stable. So let's see one by one, guys, what are benzyl ethers. We are starting to do the protection of the alcohol. Okay, so ROH, H is going to be replaced by the CH2PH group. Let's see how it forms. First of all, you have an alcohol. Alcohol in the presence of sodium hydride, H minus. H minus can remove this proton from here, give you RO minus. RO minus is going to attack over this carbon and the Br minus eliminates. You have ROCH2PH, which is the ROBN, benzylic ether. Okay. Now, till here is your protection. Alright, so it is stable against what reagents? It is going to be stable for both acid and base. Alright, ethers are, guys, very stable, right? Ethers are stable towards acids and bases. But once again, there is benzyl group. So you want to do the cleavage by the catalytic hydrogenation by taking the palladium charcoal or ranitidine or Birch reduction catalyst sodium liquid ammonia. All of these three are going to work for the deprotection of benzylic ethers. Once again, you have alcohol and CH3PH, that is toluene, got eliminated. So yes, very simple. Now, what do you call all of these groups? Let's see. ये तो हो गया simple benzylic ether, but sometimes you also have RO. So this was ROH, but sometimes it is replaced by RCH2 OCH2PH. What are you going to call it then? It is benzyl oxymethyl. Benzyl oxymethyl, that is BOM. Okay, sounds funny, but it is BOM, benzyl oxymethyl. Similarly, you have RO CH2 OCH3. What is this? Methyl oxy methylene. Okay, so that is going to be MOM. All right, methyl oxy methyl ether, isn't it? This is your methyl ether. So that is mom. Then you have ethyl ether. So that's going to be MEM, and so on and so forth, guys. You just go on changing the alkyl chain. That's going to give you different molecules. So alcohol is going to be, let's say you are having pH CH2O CH2Cl. Now, where is the oxygen going to attack? Oxygen attacks where there is a good leaving group. Now, you will say, ma'am, यहाँ पे भी तो attack कर सकता है. नहीं करेगा, because this oxygen is not a good leaving group. Okay, but the chlorine, it is always a good leaving group. Without any second thought, you can just attack the oxygen onto this one carbon. Okay, always. Yes, that is going to give you benzyl oxymethyl group. That is BOM group. Benzyl oxymethyl. Okay. Yes. How are you going to do the deprotection? जहाँ पे benzyl आ गया है वहाँ पे catalytic hydrogenation works best. After the catalytic hydrogenation, you are going to just remove this whole group to give you ROH. Similarly, methyl oxymethyl ethers. Yes, once again, methyl oxymethyl matlab MOM, MOM group. Similarly, very simple this is, guys. Let's say you are having some random alcohol. So we don't need to understand कि ये क्या है, जो भी हो हमारे पास तो alcohol है. This is the alcohol, right? So yes, let's look at the alcohol. So this is your alcohol in the presence of sodium hydride H minus. It's going to be deprotonated. After deprotonation, once again methyl oxymethylene bromide or some halide you're going to provide. Methyl oxymethylene chloride bromide, any halide you're going to provide. O minus will attack on a carbon जिसके पास good leaving group है. So Cl minus is a good leaving group. Gets connected, forms the mom ether. Very, very simple. All right. So yes, guys, these are some very simple ethers which has been asked. How are you going to do the deprotection of the mom ether, guys? What is, once again, let's revise. What is this? RO methyloxy methyl ether. This is what is the mom ether, right? What do you need to do? You need some good nucleophile to attack on this carbon and particularly remove this oxygen. Okay, and then what are you going to get? You will get back the alcohol which you started from and MEOCH2I. Alright, this is removed. So in this case, you require some nucleophile. What is that nucleophile, guys? जब भी oxygen हो and you require a nucleophile. Silicon has a high affinity for oxygen and bromide is a good nucleophile. So you will take the tri-silyl bromide or any other halide. That is going to provide a nucleophile. Okay. So deprotection takes place. All right. Now another important way of protection, या फिर reaction of protection is the diol protection. This has been asked very, very frequently in your examinations. So 1,2 diol protection will always favor 1,2 diol protection will always favor to have ketones, जैसे कि acetone or any other ketone, guys. Okay, ketones are best protecting agents of the 1,2-diol. Okay, let's say, guys, so let's say you are having cis 1,2-diol. So these two diols are cis to each other. Cis 1,2-diol. You can take acetone Me2CO. You can take acetone in the presence of an acid, or you can take C. Look at this. What is this second reagent? MECMe. But then there are two methoxys. Yes, so in the presence of acid, what happens, guys? The presence of acid, they are going to, let's say one of the oxygen is protonated. So that's going to be like this. OMe, one more OMe, but then this is protonated. So got a positive charge. Yes, and this oxygen is going to push it away. So you're going to have the oxonium ion, which is very similar to the ketone like this, OMe positive. So this oxonium ion, this is very similar to the ketone, just that the carbon is more electrophilic in nature. So this is going to be a better reactant, better reagent. So now the diol oxygen has to attack over here and the bond opens up to do the protection. So it's going to give you the same product, just that you have a better electrophilic carbon over here. Similarly, you have one more molecule, guys. This is so beautiful. Look at this molecule, third one. Yes. So this particular molecule is not at all looking like a ketone, but when you are providing acid to it, what happens is oxygen is going to basically help in the attack on the proton like this, and this becomes a CH3. This was already a CH3. This is exactly similar to this molecule, which is similar to the ketone, protonated or methylated ketone, right? Which is going to give you the same product once again. Okay, so all of these three reagents, 1, 2, 3, all of these three reagents could be asked for the 1,2-diol protection. Not could be, they have been asked in your examination, so just be careful about these three. Okay, so 5-membered ring or 1,2-diol formation. See, 1,2-diols, they are always going to be protected by a ketone. They could also be protected by an aldehyde, that is not going to be a problem, right? But we prefer to form bond with a ketone. Okay, that's going to be formed faster because the ring is smaller. The cyclization of a 5-membered ring is faster as compared to a 6-membered ring. So the 1,2-diol prefers ketones. And what is the problem with the 1,3-diol? Let's say this is a 1,3-diol. ये भी तो कर सकता है ना ketone के साथ में? नहीं कर सकता, guys, because if this 1,3-diol, if this wants to form, wants to do protection, all right, with with a ketone, then you are going to get something like this, CH3 like this. Okay, so what just happened, or let me just rewrite this once again. Yes, if we are doing protection in this way, all right, so if we are doing the protection by acetone, what will be the problem? The problem will be 1,3-diaxial interaction with the acetone that is saved, that is not present in the presence of a aldehyde, because always one aldehyde is going to have one hydrogen and one phenyl or some other alkyl group. So that alkyl group it can keep on the equatorial position, that is away, and proton could be kept on the axial position, so that the 1,3-diaxial interaction is less as compared to a methyl. So that's why the 1,3-diols, they are going to be favored to protect by the aldehydes. Okay, yes. Now we move onwards to thioacetals. See, simple acetal molecules, let's say, look over here, what are you forming? You are forming the acetal only. This is a simple acetal molecule. Sometimes you can also take the thioacetal and it has various functions like ampolung synthesis and so on. So we'll see how the thioacetals are formed and how they are going to be used. So first of all, guys, let's look at this ketone. It is a alpha beta unsaturated ketone molecule. You are protecting this by CH2CH2SH, that is 2 sulfur. It's a dithiol like this with 2 carbons in between. Okay, so in the presence, specifically in the presence of a Lewis acid BFC, Lewis acid, boron based Lewis acids are going to work the best for the thioacetal formation. So this is your thioacetal. All right, very well. Here you cannot do any reaction with it, but if you are doing the protection of an aldehyde, let's say you are doing the protection of an aldehyde by the thiol, then this proton can be very easily removed from the in the presence of a base, and it can give you a nucleophilic attack. That is, let's say I'm having butyl lithium. What will it give you, guys? It gives you a nucleophile like this, and this nucleophile can attack over any other molecule like RBR to give you one more substitution on this carbon. That is, you are going to get R dash S dash, and then you can do the deprotonation. So from the aldehyde you can synthesize a ketone, okay, by taking the thioacetal as a concept, as a protecting agent. All right, what else can you get? This is a very versatile molecule, guys. What else can you get? You can do the, you know, let's look over here. This example first. You can also hydrolyze this to get back the ketone. And if you don't want the ketone, if you want to just remove the oxygen, deoxygenation, you are going to take Rani nickel. Okay, so you're going to take Rani nickel in the presence of ethanol polar solvent so that it can provide the protons, and you are finally going to get deoxygenation. No more you're going to have the carbonyl. This is one very, very important application of the thiols. Similarly, guys, when you are having thiol, see you have three different protecting groups over here. This is an acetal, this is also an acetal, this is a thioacetal, right? And when you are providing trifluoroacetic acid, which is a strong acid, which of these is going to be deprotected first? The one which is most reactive and least stable, that is your open or free acetal. Right, a chelate is always more stable than a free acetal. So this free acetal is going to react best. It is going to be deprotonated first of all. All right, that also you have to be careful about. So these are all very, very important examples, guys, as you have seen. Right, one very, very important ether or the alcohol protecting agent is paramethoxybenzyl ether. That is, you often call it PMB. PMB ether. So PMB ether, what is that, guys? Paramethoxybenzyl. Okay, so this is very simple. On the para position, you are going to have the methoxy group like this. On and you have the CH2PH. All right, so this is your alcohol. For example, ROH. H has been removed by the paramethoxybenzyl group. So this is it. This is the paramethoxybenzyl. So this is your alcohol in the presence of a amine base. You are going to deprotonate this, and the alcohol going to attack on the benzylic position. Since the benzylic position can give you SN2 reaction, this is your ether, paramethoxybenzyl. Now, very important part is the formation is going to require DMAP, which is nothing but a coupling agent. DMAP is a coupling agent. ठीक है, ऐसे याद रखो, DMAP is a coupling agent. Okay, why and how that we will discuss in future, but yeah, for now it is a coupling agent. And DDQ specifically works for the deprotection of the paramethoxybenzyl ether. Super important this is. Super, super important. Okay, we are going to see this. How does it do so? इसकी mechanism हम करेंगे when we are actually looking at the questions which are asked in your examination. Okay, very, very important, guys. DDQ oxidation. It is itself dichloro-dicyanobenzoquinone. All right, it's a quinone molecule. So it is going to get the hydrogens and remove the PMB ether, break the PMB ether down to give you back the alcohol. So this is again very important, guys. Last few examples that you also have to see, and because you might get confused about it, that's why. Trityl ethers, that is RO. What is a trityl group, right? What is a trityl group? The bulky group which has 3 phenyl rings. So this is a trityl carbocation. Okay. So yeah, obviously you cannot carry out a SN2 reaction on this carbon because there are 3 phenyl groups, but you can definitely do an SN1 reaction. So triphenyl methyl ethers. Let's look at this. What is happening? There are two alcohols. One is a secondary alcohol, one is a primary alcohol. So whenever there is a choice and we want to protect the primary alcohol, तब हम क्या करेंगे? We'll take such a big molecule which is only going to protect the less hindered alcohol, that is the primary alcohol. 100%. Okay, so you see the selectivity. It is very, very important, guys, that we somehow, anyhow, if we get something selective, उससे ज़्यादा important तो कुछ हो ही नहीं सकता. Similarly, here you are having an acetal, here you have a benzyl oxy group, TBS, alright, all of these. लेकिन how are you going to do the deprotection of trityl? By adding acid. Strong acid is going to do the deprotection of the trityl back to the alcohol. Okay, so it is very important. Why is it important, guys? Because it has selectivity. That is 1 degree alcohol is going to be more reactive than 2 degree than 3 degree. 3 degree to karega hi nahi because it itself is a very bulky carbon group. All right. Okay, Silyl ethers. Yes, Silyl ethers, that is ROSIR3. Something like this. This is your Silyl ether. So oxygen having a very high electron affinity for the silicon group. Okay, silicon and oxygen have a very high affinity for each other. So what's going to happen? You're just simply going to take ROH and try silyl chloride in the presence of a base. It's going to give you this molecule. Sometimes in your examination, this is often asked Me3SiOTF या फिर ऐसे TBS OTF, ये दोनों मेंशन किया हुआ है. What is TBS OTF? So TBS would be tertiary butyl dimethylsilyl group, and OTF to pata hi hai, it's a good leaving group. So how is it going to attack? The nucleophile, the alcohol, is going to attack over TBS and OTF is going to leave. इस तरीके से ये काम करेगा. Tri alkyl silyl and OTF is going to leave. Okay. Yes, now you have the ROSIR3, that is the silyl ether. Now what guys, this is okay, silyl ethers are very strong because silicon and carbon have the similar electronegativity. So that's why they are going to be very strong. But how are you going to deprotonate? Whenever you see silicon, you are going to look for a fluoride source, OH minus source. All right, all of them, all of these are going to be hard acids, hard bases. Okay, so whenever you see silicon, you are going to see for a fluoride or a hydroxide source. ये देखो tetrabutyl ammonium fluoride है, F minus है. Okay, and that is going to free up the oxygen like this, ROH R3SiF molecule. So this is what you are going to get based on the silyl ether. Alright, so R3SiOTF is some same trialkyl silyl trifluoromethane sulfonate. Now you sometimes get TBS OTF or TBDMS, TIPS. What are all of those things? Those are just the change in the alkyl group, nothing else. The silicon is doing the job as it is. Trimethyl silyl ether, ROTMS, that is once again alcohol. Once again you are having the trimethylsilyl chloride in the presence of a base. You are going to get this molecule ROSIMe3. Okay, this is very very important. How do you do the deprotection? Once again I'll have the fluoride source, F minus attacks over silicon and the alcohol becomes free once again. Okay, now there are some molecules like this. What is this? It is a dihydropyran. It is a dihydropyran. Pyran is a six-membered ring having oxygen. Dihydropyran means pyran was usually going to have two double bonds. But here two of these carbons are having hydrogen on it. So it's a dihydropyran, right? How is it going to give you ether or acetal? See, look at this. When the same carbon is connected to two other oxygens, ठीक है? It is termed to be a acetal. Tetrahydropyranyl acetal 100% formation takes place when at 20 degrees centigrade we are first of all providing acid to it. The hydropyran molecule acid is provided. This carbon once again attacked by the alcohol. So this is your protection group. How are you going to do the deprotection, guys? It is so simple. In the presence of acid, just like all the acetals are being deprotected. Okay. Yes. So acetals are basically stable towards bases but unstable towards acid. Now all of these questions have been asked in previous years, guys. June 2012. Look at this. Okay. So you have question number 1 from June 2012. I hope you will be able to do this, guys. Yes, very interesting, all of you. June 2013 is question number 2. Once again, June 2015, one more question on deprotection. Okay, so this is our question 3. Yes. Question 4, June 2016. All right, question number 4. Then look at this, question number 5. Okay, this is somewhere from yeah, December 16. It is December 2016. So you see back to back questions are being asked. June 16 में भी आया है, December 16 में भी आया है. Right? So try to solve these questions by yourself. And once again, June 17 में भी आ गया, the same reagent DDQ. Lastly, December 2017. So you see guys, every examination, every consecutive examination is having at least one question on the protection and deprotection. Okay. So if you just know the simple series, you will be able to answer all of these questions. Okay. Yes. So this is it guys, and we have discussed plenty of important things. अभी आप क्या कर सकते हो? You can watch the previous sessions also. All right, and just try to do all of these questions. I will make you do these questions in the next video now. So bye everyone. Once again, these are little topics that are only going to help you in your in scoring marks in the examination. So it's like a last minute cheat code type of stuff. All right, yes, but definitely I'm going to help you in the complete understanding of the topics also, but after this examination. So yes, bye everyone, take care.